what I'm going to do now, I will introduce our panelists, and then I will ask them to give several minutes of introductory comments. And then after their comments, then we're going to open it up to questions for you, and the microphone there is in the center aisle. And so what I would like to do is I'm going to start with Dr. David Titley, who will be joining us soon right here on screen. And I'm going to read a bio on each, and we've all been to events where we've been read bios. I have chosen what to give to you because it's very important information, so that you know, I think, the credentials of our distinguished panelists. And so, Dr. Titley, Senior Scientist, Department of Meteorology, and Director for the Center for Solutions to Weather and Climate Risk. His education includes a Bachelor of Science in Meteorology from the Pennsylvania State University. He has a Master of Science and PhD in Meteorology, and a Master of Science in Physical Oceanography from the Naval Postgraduate School. And he is a Fellow, Massachusetts Institute of Technology Seminar on Foreign Politics, International Relations, and National Interest. Dr. Titley is a nationally known expert in the field of climate, the Arctic, and national security. He served as a naval officer for 32 years and rose to the rank of Rear Admiral. Dr. Titley's career included duties as Commander, Naval Meteorology and Oceanography Command, Oceanographer and Navigator of the Navy, and Deputy Assistant Chief of Naval Operations for Information Dominance. While serving in the Pentagon, Dr. Titley initiated and led the U.S. Navy's Task Force on Climate Change. He has spoken across the country and throughout the world on the importance of climate change as it relates to national security. The Department of Defense requested he present on their behalf at both congressional hearings and the Intergovernmental Panel on Climate Change meetings from 2009 to 2011. He is currently a Senior Scientist in the Department of Meteorology at the Pennsylvania State University and Founding Director of Penn State Center for Solutions to Weather and Climate Risk. Next, I would welcome Dr. Titley. Next, I would like to welcome Dr. Jack Fishman. He joined the faculty of St. Louis University in 2011, where he is a professor in the Department of Earth and Atmospheric Sciences, and was also appointed the Director of the Center for Environmental Sciences that same year. Prior to coming to SLU, he worked at the NASA Langley Research Center for 31 years, where his research focused on the area of tropospheric chemistry for more than 3 decades. In the early part of his career, he worked under the tutelage of Nobel laureate Paul Crutzen, where he developed photochemical models of the atmosphere. The results from these models led to the hypothesis that anthropogenic emissions significantly impacted the global tropospheric ozone budget, a premise that was later confirmed. And I will just add, as being a moderator, you don't have to understand what you read. You just have to read. Since the mid-1980s, Dr. Fishman has pioneered the use of satellite observations to provide a unique and eye-opening perspective of the extent of global pollution. In 1992, he was the mission scientist for a multinational NASA-led aircraft field campaign that confirmed and provided an explanation for his satellite findings of extensive pollution from biomass burning in southern Africa and South America that circumnavigated the southern hemisphere. 13 countries, 7 aircraft, and more than 300 scientists and support personnel participated in this 2-month field campaign. He has authored or co-authored more than 100 citable works in the peer-reviewed literature and has given numerous presentations at national and international conferences. He has been a member of 2 NASA satellite science teams, and he was one of the leaders of the Science Working Group for the Geostationary Coastal and Air Pollution Events Mission, NASA's next planned atmospheric chemistry mission, which is anticipated to be launched within this decade. Welcome, Dr. Fishman. Next, we have Kyra Krakos. Dr. Krakos did both her undergraduate and master's in integrated biology at Brigham Young University, where her thesis work focused on the impacts of invasive species on the pollination systems of several tropical plant species. She did her doctorate at Washington University and was a visiting researcher at Harvard University. Her dissertation focused on the ecology and evolution of plant reproductive biology using the Enothera genus as a study system. I think I came close to that. Kyra is an assistant professor of biology at Maryville University and a research associate at Missouri Botanical Garden. She teaches courses in ecology, plants and people, evolution, conservation and sustainability, and botany. Her lab focuses on two main areas of research that emphasize the need to understand the dynamics of the natural world in a changing environment. First, she studies the evolution and ecology of plant reproduction, including plant-pollinator interactions and breeding systems, and the implications for these systems under climate change conditions. Second, she is the principal investigator for the Maryville Honeysuckle Project that is studying local green solutions to invasive species. She is a member of the Botanical Society for America, American Women in Science, and serves as the co-director of the Missouri State Junior Science, Engineering, and Humanities Symposium. Dr. Krakos is currently a co-principal investigator on a broad project with 9 other St. Louis scientists that is centered at Shaw Nature Reserve. This research focuses on the effects of climate-driven changes and plant pollinator networks using historical records in comparison with current data. She is a frequent invited guest speaker at academic and local institutions. Welcome, Dr. Krakos. And if we could give each of our presenters Titley, and I'm going to start with you, Dr. Titley, and if you would just give a few minutes of your introductory comments.
Okay, well thanks so much. First, I guess we're doing a sound check here, so is this working out or not?
You're sounding good.
Okay, I see a thumbs up. That's a really good sign. I'll keep this really, really brief. I watched the film not too long ago, Earth the Operator's Manual, and my opinion is it actually stands the test of time pretty well. Some things kind of after you make it a year or two, it starts looking like it's that old. This, I think, with Richard Alley kind of as the anchor, has really stood the test of time. So the messages, they were pretty good. I would just add, if anybody asks me, like, why is climate change a big deal or a big deal for national security, it's really 3 things. It's about people. I mean, with all due respect to the polar bears, we're not going to change our energy system. We're not going to change, some pretty fundamental things for polar bears. I like polar bears, unless they're chasing. But it's really about people. It's about us. It's about our families. It's about our children. It's about our parents. It's about people in our community. We're the ones who are going to get impacted by climate change. You hear all this stuff, you hear about temperatures, hurricanes, tornadoes, droughts, floods, everything. If you want to think about it in sort of one term, I kind of think about it as water, because we're fundamentally starting to change the distribution and even the kinds of types of water. Too much, too little, wrong place, wrong time, liquid where it used to be solid, melted where it used to be ice, acidic where it used not to be. So water is really, if you think about it, an awful lot of climate change kind of comes into that. And then the third thing is, as we know, James Carville very famously said with President Clinton, it's the economy stupid, right? Well, when I look at climate change, it's the change piece of climate change that has us really so concerned about this. As I think probably everybody in the audience knows, the climate on the Earth, when you look in terms of hundreds of thousands and millions of years of time, the climate's always changed. I mean, really since the beginning of the Earth, it's always changed. It's up, it's down, it's something. But what we've had is about 8,000 to 12,000 years of very, very steady and stable climate. I tell people, unless you live in San Diego, California, or maybe on the northern eastern coast of Italy or something, it's not like it's perfect and ideal and optimal, but it's being stable. So what we've been able to do is, have agriculture, civilization, and the next thing you know, all of us are carrying these things around, iPhones. And it's because we were able to, as a civilization, have 8,000 years where we kind of knew where the rains were going to be, where the snow was going to be, what you could grow in what place. And now we're changing. you know, if we somehow were in an alternative universe in which we were sucking carbon dioxide out of the atmosphere and the climate was changing just as fast but getting colder rather than warmer, we'd be in this same room today, right now, trying to figure out what to do about it. So it's this change that is the real challenge for us. And frankly, is the climate going to change faster than we and all the ecosystems and the services that we use to support ourselves can adapt? And that's kind of the $64 question. So I'll stop there. Thanks.
Thank you very much, Dr. Titley. And Dr. Jack Fishman, I will turn to you.
Thank you. A little bit of background about myself. I grew up in the St. Louis area and then moved away for 35 years, and now I'm back. I've been fortunate to be able to do a job which is a lot of fun. It's challenging as a research scientist from NASA, and I never really considered myself a climate expert until I moved back. And what I'm here to do is sort of elucidate on the fact that there's a lot of misconception out there that there's still a climate debate, that there are a lot of skeptics, that the scientific community is still divided. And the message I want to get across here is that there really is no debate among the climate scientists. The ones who we're hearing about on the radio that I've heard here since moving back to St. Louis, it's sort of fictitious. It's mostly done for attention. There is no real scientific basis for the arguments you've heard that global warming is not here. And the IPCC report, the Intergovernmental Panel on Climate Change, is put together by a lot of very good people who work sincerely to try to understand the science behind climate and climate change. So I view myself more as a resource to try to clarify some of the information you may hear that makes you wonder why we're studying the problem at all when you may be hearing from other sources that there is no such problem. Well, the problem may be exaggerated by certain others. It's sort of like, I'm not an alarmist, and do we need to be an alarmist? I personally don't think we have to. But I think we need to take precautions and act prudently. And watching this PBS program sort of shows you how we can sort of make progress and become less dependent on fossil fuels. Eventually stabilize carbon content in the atmosphere, and eventually adapt to the climate without it going out of control. If it will go out of control, I'm not 100% convinced it will. But nevertheless, it is changing, and there are things we can do.
Thank you, Dr. Fishman. Dr. Krakos.
Thank you. So my role here is definitely to talk more about, I think, the interaction between climate and the living world, particularly the plant world. And while my colleagues have very global, broad perspectives, the research that we're doing currently is very much focused on the microclimate and the impact on those habitats, on microhabitats, and then scaling those up to community effects, which is also, I think, the perspective of the part you might not think about. When people say climate change, I think we do think about the polar bear on the iceberg floating away, and it's a very sad image. When I hear climate change, I get very worried about food sources and the disruption between a lot of interactions in our ecosystem. The one I focus on is, of course, pollinators. And a lot of times I hear people say, well, is that a big deal? 80% of the plants on this earth require a pollinator. We can't do that work. We are not bees. We have absolutely no capacity to work like that. And for those who perhaps need a little persuasion that plants are incredibly important, without pollinators, there's no chocolate. That's always my big selling point. But the project that I'm a PI on, 3 years ago, we came across this remarkable, centered here in St. Louis, sort of time capsule of information in which there were insect collections and records of when plants were blooming from over 100 years ago. It's a gold mine of information, and it was molding away. And from that, it's a little Jurassic Park, I realize, but you collect the pollen and you can see who was blooming and when, and even more important, what interactions were happening. And so we started to track this, just the plants initially, at Shaw Nature Reserve about 3 years ago, and immediately saw that there had been 2 to 3 to sometimes 4 month shifts in blooming times. Not just in when things bloomed, but how long. which again, this disruption of things interacting that were never meant to interact or that did not involve interacting together. And now we're adding in the pollination layer. It takes an enormous amount of detailed work, and my lab, and I use undergraduates like crazy for this. It's fantastic work for them to do. But we scale that up, and there's 9 major scientists who work on this project. We scale that up to look then at the impacts on community level interactions. And not just here in Missouri, although the project's centered here in Missouri, but what that means particularly for the Midwest area and all of the feeding of the world that the Midwest does. And so from very small little bees come very important results and interactions on our life, and climate change impacts those areas very importantly.
Thank you very much, Dr. Krakos. Okay, it's your turn. If you have a question for one of our panelists, I will invite you to the center aisle. There is a microphone there for you. I would ask that you come to the microphone. Otherwise, Dr. Titley is not going to be able to participate with us. And so we need the microphone so he can hear your question. And so if you would come to the center aisle with your question, and you can line up, and then perhaps direct it specifically to one of the panelists, or you can throw it out and whoever grabs it first. Yes, sir.
Yeah, I am, by the way, concerned about the polar bears, Admiral. But because I went to the St. Louis Zoo program that was really good about with a wildlife biologist, and he was talking about how they can't swim forever. So I'm concerned about those guys. But anyway, to the St. Louis U professor, I have a friend that's a town and country resident. So you guys from town and country. But he is also probably the world's biggest skeptic about this. And he's telling me, and I don't buy it, but he's telling me that, oh, there are lists of scientists that are still out there that are still saying it's not happening, it's not human-caused, etc. What do you tell these skeptics?
Okay, I'll take a first shot at that, and hopefully the other panelists can jump in. You know, you can probably find somebody who still thinks the Earth is flat if you ask all 7 billion of us that are here. I mean, you can always, if you look hard enough, find somebody who, for whatever reason, you know, they may be absolutely, legitimately unconvinced, they might have an agenda, it doesn't really matter. You can always find somebody. But a number of polls have shown, you know, that 97% of scientists, which is a pretty high number to agree on anything. I mean, I'm in academia now, I'm at Penn State, and I'll tell you, just getting 3 or 4 scientists to agree on where to go to lunch for a day is a non-trivial feat. So get 97% of scientists to agree on what is frankly cutting-edge 19th century science. Because this is, you know, there's guys named Fourier, you know, back in the 1840s. Arnhus back in the 1860s, Tyndall about the same time. Those were the guys, these 19th century guys, and unfortunately, I'm sorry ladies, they were all guys, but they were the guys who figured out that the atmosphere, there were certain types of molecules, primarily water vapor and carbon dioxide, that would act as a blanket, that would actually hold the heat. And many, many people have basically done the experiments to confirm that, yeah, these guys were right. And we know that we're putting in new carbon dioxide. You can tell by isotopes. It's really, really easy. I mean, we know that to about the same degree that we know what gravity is. We know that we're digging up old carbon and putting it into the atmosphere. And we have a very, very good understanding of the very basic physics that that's going to cause an energy imbalance. And then you can go and measure it. I mean, I was, one of my most fun jobs in the Navy was I was navigating on an old destroyer. And just looking at the audience here, there's a couple of you guys who would know that there was life before the global positioning system, and that, like, navigation actually out at sea was more than just press a button and, you know, you just kind of read the GPS. So what you did, if you didn't want to go work for Walmart rather unexpectedly, was you looked at all the different kinds of data. You didn't trust any one kind of data 100%, but you sure looked at everything. And you can do that. You know, it's like, okay, you can say, hey, that whole theory thing, I don't understand theory, I don't care about theory. Fine. Look at the observations. Look at the air temperature. Look at the ocean temperature. Look at the ecosystems. Have Kyra talk to you about what the ecosystems are doing. They're either going poleward or they're going up elevation. Look at what the lakes are doing. Look at what the Arctic ice is doing. You know, maybe you could explain one of those things kind of without climate change, but when you put them all together, you gotta have a really, really, really complicated theory to try to explain all of that stuff. Usually it involves conspiracies. To be able to somehow figure all this stuff out. So, you know, just to summarize, 97% of scientists do agree with this. Every national academy that studied this in the world agrees with this. The theory is based on very solid 19th century, 1800 science. And if you don't believe any of that, there's about 8 or 9 independent or different kinds of observations that all point to the same thing. So that's kind of how I look at that. Thanks.
Thank you, Dr. Titley. Would you like to respond?
This is just another kind of piece of evidence, but coming from strictly the living things aspect. Across all 5 kingdoms of life, you could say 6 if you're feeling whimsical about the archaeobacteria, but across all 5 kingdoms of life, biologists who never actually even talk to each other, every single kingdom sees climate change impacts. Whether you study moss or whether you study plants on a angiosperm flowering plant level, if you study polar bears, if you study lichens in the Arctic, every single kingdom sees impacts from climate change. And that is pretty compelling evidence. Again, that would also be very tough to fake.
I've got a 3-part answer to your skeptic's question. The first part is that I started my research in the era of trying to understand the chemistry of the atmosphere. And one of the things that was being questioned was this thing called the ozone hole. It was observed, no one quite understood what was coming off. Eventually it was, as you all know, I'm sure, that the purpose, the cause of it was fluorocarbons. But if you follow the debate in the early 1980s, okay, there were alternative theories, which made sense, sort of, until they were looked at with more detail and proven sort of incorrect. Now, in 1992 or so, I'd written a book for general audiences about global change, and because of that, I was at NASA at the time in a research center. They called me in and they asked me about the fact that people were calling in to the center, telling them, why are we wasting all this money studying ozone in the stratosphere, the hole, and that kind of stuff, when indeed it's all a natural process, and I know it is because I've heard it on Rush Limbaugh. So what they did is, Mr. Limbaugh was quoting this book that was written about, I think it was called The Hole in the Theory about the Ozone Hole, or something like that. And it was being quoted a lot by him and by some other radio personalities of that same genre. And so my public relations people at NASA finally said, read this book, and this is what they're all talking about, that the hole is fictitious and it's a natural occurring thing. Well, the book is very convincing, and the book has some scientific truth in it. But it doesn't have the whole truth in it. It's got a lot of anecdotal type stuff that is true in a sense, but when you look at the whole thing, the whole package, it really doesn't make much sense. Like, one example is that how can chlorofluorocarbons, which are, there's tons of it put into the atmosphere, but that's nothing compared to how much chlorine goes in the atmosphere from salt coming out of the ocean. You have a lot of spray coming out, little salt particles, and you've got many thousands of times source of chlorine going into the atmosphere. How can man-made chlorine be important? Well, the salt is, as we know, we put it in the water, it's soluble. Okay, that same salt in the atmosphere of rains gets washed out. But it's a very convincing argument if you don't read the whole story that, yeah, gee whiz, the man-made chlorine can't have much of an impact. So that's part one of my answer. Now, I've gotten engaged with that. I've forgotten parts 2 and 3. The second one is, I do listen to Rush Limbaugh occasionally because I am a big Cardinal fan, and he happens to be on the same station that Rush Limbaugh is on. So during the day, if I have to go out somewhere, I hear this guy talk. And when I moved here, I caught Mr. Limbaugh a couple of times, and he had on his favorite climatologist, who is a professor down at the University of Missouri, who talks about the fact that global warming is not real. And what he does is he says, okay, we're going through a heat wave, and it was March of 2012, I believe, and he said, well, you know, it's really warm now, but it was a lot warmer in March of 1894, and we didn't have, you know, nearly as much fossil fuel usage then, so how could that be the cause? And again, what I'm warning is that these people who make these kinds of statements throw out this anecdotal evidence that it was like this then, but, you know, why is it like that? But they don't offer an alternative, okay? So that's what the skeptics are doing. And even some of the papers that are by fairly well-respected scientists have published peer-reviewed literature, okay? And this means that they throw out a theory, goes through the peer review, and it's accepted. Scientists by nature are skeptical, okay? We have to be, that's how we make a living. Because you advance, science is truth, and the only way to get at the truth is to understand what isn't true. So that's my second part, and I want to go to my third part, if I can indulge in this real quickly. I was with NASA for 31 years and 3 days. During that time, I was a NASA supervisor, and I had to go to some supervisory school. One of the courses I remember very distinctly, so this thing I can remember 20-some-odd years later. There were a group of 24 of us in this class going through our management training. And after we came back from lunch, they said, sit down and watch this movie. Okay? And the movie was 12 Angry Men. Now, most of you know what that story's about. And you're watching this movie, and Henry Fonda is a holdout on this jury. It sounds like all the evidence is that this guy is guilty, except for one. So we're watching the movie. We don't know why we're watching the movie. So after the movie, the moderator, the facilitator, says, okay, he gives us a sheet of 1 to 12. Go ahead and list the order in which the various jurors changed their mind. You had the baker, you had the plumber, and you had the policeman. And so we did that without consulting with anybody. So 24 of us got together. The next thing she did was, okay, get into 4 groups of 6. And between the 6 of you in each group, determine what the order is that they change their mind. Well, the bottom line is there's 24 of us individually trying to figure out the answer. Nobody got it right. One person almost got it right. When the 6 of us worked together, okay, in 4 different committees, 3 of the 4 groups got it exactly right. One group missed it by 1. So this is what's happening in the climate world, okay? You have a lot of theories out there, a lot of hypotheses out there. But this was first put out in the late 1980s, okay? Jim Hansen from the Goddard Institute of Space Science put out this hypothesis before the public and Congress. It took a lot of chutzpah on this part to do that. But what's happened is the world has gotten together really good, intelligent people, a lot more intelligent than myself, quite frankly, that have looked at the scientific aspects of climate change, the physics, the chemistry, whatever, and they're concluding this. This is a group of hundreds of scientists that have gotten together, and their consensus is indeed global warming is real, and global warming is man-made. Probably took too long, but...
Thank you very much. Another question? Someone come to the microphone. Thank you, sir.
Actually, do you mind if I put in one quick comment about the previous topic as well? While there are a lot of scientists out there that I have a lot of faith in, some of the studies that we've seen saying that, well, global warming, it's really not out there. If you take a little bit closer look at some of those studies and some of the people purporting to tell their spin on those studies, you find that the sponsors of those are having less than non-biased reasons for saying that there is no global warming. So take it with a grain of salt, what you see in the press. Just as an example, the tobacco companies back years and years ago when tobacco was determined, hey, this is bad. All the scientists came out pretty unified, but there were still a few out there that weren't saying that tobacco is bad. And by using that information that they paid for, by the way, they being the tobacco industry, and just being able to stir up enough questions slowed everyone down from getting rid of it. I think this may be very much in that same vein, so
Okay,
you have to watch out for that.
thank you. Do you have a question?
Yes, I do have a
Okay.
question. And thank you for letting me
Sure.
join in on that. Here's my question. I'm seeing some of the graphs looking at CO2 and temperature or aggregate temperature around the world. It really looks like it's very, very noisy data, number one. Can any of you give me some sort of a feel for what the lag effect is there, plus or minus? I mean, if we were to stop producing CO2 now, which I know is impossible, but how long is the effect going to be lasting, and how long, well, what sort of median time frame that we're looking at that we're feeling right now today? Some of it was from yesterday, but some of it was from X number of years ago. Can you give me a feel of that?
Good question. Who wants to jump in?
Okay, do you want to go ahead there, Jack?
I was going to yield to you.
Okay, I mean, let me just take a really quick shot at that, and then we can have NASA kind of clean up behind Navy there. So the way we look at this, or I look at this, is carbon dioxide is kind of a gift that keeps on giving. And unfortunately, one of the things about carbon dioxide is it lasts a long, long time, and it's in thousands of years in the atmosphere. Other gases, like methane, actually only last maybe a couple decades or so. So they go away pretty fast, and soot is a few days, it's weeks. But carbon dioxide lasts for a long time. So what we have today is an Earth that frankly is not in balance. We have heat coming in that is able to leave. So even if we stopped today, somehow, we were the czar of the world's energy and we go to zero carbon dioxide by tomorrow morning, we have still built in at least decades, at the very minimum, to come into a temperature equilibrium, and then most likely somewhere between decades and centuries for the ocean and the ice on Greenland and the ice in Antarctica to actually get into balance. And there has been some recent studies just in the last couple of months, peer-reviewed literature, so basically, other scientists have had to look at stuff. And the bottom line, it basically says is that for every degree of Fahrenheit that we've increased the temperature, and in rough terms, we've gone up about 1.5 degrees already since the beginning of the Industrial Revolution. For every degree Fahrenheit, that's about long-term 4 feet of sea level rise. 1 degree Fahrenheit is 4 feet of sea level rise. Now, if I want to sound dimensions, I'll say metric, and it's Celsius is 2.3 meters. That sounds talking about. But it's 1 degree Fahrenheit is about 4 feet. And that will take a long time to get into balance. So that's really it's a very short-term answer. Some of the gases would weigh really pretty fast. Carbon dioxide hangs around for a long time. It would take at least decades to get into balance, probably like a century or so. And then the real long-term piece is getting the heat of the Earth to balance with the ice, and we're going to see some sea level rise because of that. So Jack, you feel free to say what the apple meant to say. It's all I think I said here.
That was an excellent answer. I don't think I can improve on it. But I can give one analog. Like I said, my area of expertise is atmospheric chemistry. And in the book that I wrote, I talk about the trilogy of global change. One is, of course, the stratospheric ozone hole. And we finally understand why it was happening because of chlorofluorocarbons. And it was really a wonderful political example. The whole world got together to ban the use of chlorofluorocarbons so that we stop putting chlorine into the atmosphere. It is working. It's working really well. The amount of chlorine has gone down. It peaked in about 1995, and unfortunately the ozone hole has not gone away. It is showing signs of possibly getting smaller, but like David said over there, over the State College, there's a lag effect, okay? So the ozone hole is now predicted to go away. Originally it was predicted to go away by about 2050. What they did the countdown when they first made these predictions is the temperature of the planet warming, which is causing a cooling in the stratosphere. So the chemistry that is going to eventually heal the ozone hole is much slower than back in 1980 when they made these predictions. So now the general consensus among the scientific community is that the ozone hole, yes, we've gotten rid of the chlorine, but the chemistry has changed. What we thought might take 50 to 75 years probably takes more like 75 to 100 years. So that's a good example of the time lag of stopping something cold turkey, or relatively cold turkey. What you can do with the chlorine, because that is totally man-made, and we can live without the chlorofluorocarbon compounds. Air conditioners use stratospheric safe type chemicals now to cool. But energy use and CO2 in the atmosphere is a much, much more complicated problem. And unfortunately it's become very political. And that's the real problem here, is that it's no longer a climate debate, it's more or less a political debate. And I'll say here, but for what it's worth, probably the worst thing that happened to the climate movement is Al Gore winning the Nobel Prize. It all of a sudden became very politically identifiable with a certain group of thinking within the political genre, and there's really doesn't make any sense at all to try to reduce, not to reduce CO2 emissions, but yet we're hearing more of a political debate than a climate debate, and that's where it's gotten to, I'm afraid.
To follow up maybe just a little bit, if we were to cut off the CO2 now, given the lag effect that you guys are talking about, how much would you expect the temperature of the Earth to increase before it starts going down again? I mean, we've gone up about 1.5 degrees Fahrenheit. How much more is going to go up just with what's already cooked in the book, so to speak?
And that's why I say I'm not a climate expert. David, do you have some insight into that answer?
Yeah, I think the number is roughly 1 degree Fahrenheit, degree to another 1.5 degrees to get to equilibrium here. It's about that. If you could somehow, go to zero tomorrow for future emissions. So we're, think very roughly, you're kind of halfway to what we've already baked in.
And you have to remember that the same way that some of the scenarios you talked about, we didn't anticipate some of those things. We didn't anticipate warming. Stop cutting down our trees, particularly our rainforests. Trees are magnificent at fixing carbon, and they do a great job of mitigating a lot of the damage done on the planet. Plant more of them. Stop cutting them down. Let them do their job in keeping our planet in balance as much as possible. And with more of those, there's our interactive effects, then you wouldn't know if we had more of the rainforest present, et cetera, or stop cutting it down, what kind of effect that would buffer against. We know it does that. We know that particularly the rainforest in its location around the equator does a great job of fixing carbon dioxide and pulling it out of the air, and then holding it against the future. But we are compounding our problems by not only dumping CO2 in our atmosphere, but then clearing our lands of the natural cycling processes.
Thank you very much. I think we're going to go on to another question now.
Thank you. And what your comment was a great segue to my question. I always find it interesting, even in The Inconvenient Truth, and that a report that, for instance, that the UN issued several years ago that talked about livestock's long shadow, and a lot of the data that's coming out that talks about that the methane and greenhouse gas emissions as a result of our livestock production is greater than all transportation of the world combined. And yet that's something that's really not talked about. And when you look at the growing populations of the world that are becoming more affluent, and with that they're consuming more animals, more livestock, and we're losing about a South Carolina size area of rainforest every year because it's being cut down to grow crops to feed the livestock. And so this is really, many people feel that this is a problem. And so why is it not part of the conversation when many feel that it is such a significant aspect of the global warming and loss of biodiversity and just the simple fact that it takes 90% more land, 90% more water, and 90% more energy to produce an animal-based diet than it does a plant-based diet. So I'd just like to hear your comments about that.
Dr. Krakos, I think that's you.
Humans are strange. I like that you brought up the aspect of where is that dialogue happening. At the Ecological Society of America national conferences that happen every year, it's a huge part of the discussion. There's whole sections devoted to what should the world diet look like. And I mean, all aspects of these problems. What I like is that you centered on our lifestyle choices. The health and happiness of humans on the planet is paramount. That's my species, that's what I'm voting for. But I think it's pretty clear that we all can't live on the planet the way that we do currently here. We can't keep living that way. But nobody likes to hear that. They really don't. It's one of the reasons the conversation is so difficult. If you tell humans they have to change their lifestyle, stop smoking, start running, eat more plants. I mean, you've all sat in front of your doctor and don't know. It's very, very difficult, I think, for just human nature. That said, I have tremendous optimism that we are capable of doing this. The CFCs is a great example. I actually use that in my ecology class as one of the most remarkable instances where we acted globally for self-preservation. And it means we can do it. We just have to have the will and care about each other enough. I think it takes a shift in looking more at stewardship of the planet and of each other and of our own health rather than consumption and control.
Let me just amplify on that and the CFC problem. If you remember, maybe you guys are too young, but there was a lot of resistance to it initially, primarily by the CFC industry. But the resistance sort of broke down once the CFC industry found substitutes for these chemicals that would not harm the stratospheric ozone layer. So yes, there's a lot of scientific evidence that says yes, we shouldn't do that. But on the other hand, there was also the lack of resistance by the industry because they found a substitute and they wouldn't have to lose money because of that. So again, I think the global climate problem is as much financially, their stakeholders, their profits being turned or not being turned. And there was an analogy in the chlorofluorocarbons. But eventually, I'm pretty confident that we'll come to a consensus that we need to do something to decrease fossil fuel usage.
Okay,
I see. Go ahead.
No, Dr. Go ahead.
Yeah, just very, very briefly. I mean, I completely agree with everything that's being said there. I mean, if you go back a few hundred years, you sort of look at human norms. Human norms were sewage ran down the street because, well, that's just kind of what we did, and you didn't really deal with garbage or sanitation, and nobody, it's just how we lived. And if somebody, imagine if you just went into the 1400s and said, no, you're going to spend all this money and dig pipes and do this, do that, people would have thought you were crazy. We evolve. We evolve over time, and my guess is, you could come back a couple hundred years from now and you would say, wow, they spent all this money raising cattle and eating meat and doing all these things. What were these guys thinking? So we'll evolve. We'll get there. It'll just take maybe a little bit of time, but we're going to get there.
Thank you very much. Next question.
I'm Ron Trimmer. I had my PhD from St. Louis U, and I worked with NASA and NOAA when I was working. I'm retired now, but I want you. You're all probably customers of Ameren, and our schools and institutions own the stock. I own the stock, and I want to I want you to think about joining and putting pressure on Ameren. Ameren burns and produces twice as much electricity from coal as the national average. Almost 80% or over 80% of Ameren electricity comes from coal. The national average is like 40%. And Southern Illinois, or Illinois, is first in soybeans, second in corn, fourth in hogs. And the scientists, Union of Concerned Scientists, have predicted that like by 2040, our crop yields will be half of what they are now because of the increase in drought and the wetter springs and so forth, the change. So I would like to urge the people here and the institutions to try to put pressure on Ameren to move towards zero carbon renewable energy.
Okay,
So
you have a
I
question?
guess my question is, will you do that?
Well, do you have a comment? Are we move on to the next question?
I think in those little details, not little details, but the nuts and bolts of fixing things like that, it is very important to be a proactive voting citizenship. So absolutely, these kinds of things.
Yeah, I'll just say, I gave a talk in Norfolk a couple years ago, Norfolk, Virginia, and I was asked a somewhat more general question, but it was, how do we get Congress to respond? Because we see all these problems. The sea level rise is a huge issue in Norfolk, so how do we get Congress to respond? And basically what I did is I held up a mirror to the person who was asking the question. It's like, Congress really, really, really wants to be reelected. So they will respond to what is important to the voters. So if it's important to the voters, to you guys, then it becomes important to the congressman. I'm saying this, I'm about 2 miles away from Capitol Hill as I speak, doing this. That's what they'll care about. But if it's not important to the voters, we're not going to change the regulatory and the congressional environment. So it's really, Congress, everybody says they're not responsive. They're really responsive. But they're responsive to the people who put them in office. So that's really, so I kind of turned that question back to the audience that I'm looking at. And it's like, how are you guys going to change this? Because this is going to be done at the local level. The last place that figures out climate change on the face of God's America is going to be Washington, D.C.
Next question.
I just wanted to ask a little bit more about the pollinators and what kind of effects those are going to have on climate change. I mean, we all hear a lot about colony collapse disorder, but I don't know that that's related to climate.
I'm sorry, ma'am. Could you speak into the microphone a little more? I can't hear you.
I was asking about the pollinators and the impact of the pollinators on climate change, and just saying that, we all hear about colony collapse disorder, and I don't know that that's related, but it seems like the impacts could multiply each other.
Do you want to take this one? So let me give you an example of, say, 5 things that could go wrong if even flowering times shift by 2 weeks. The first one would be that a plant entirely misses its pollinator. And then what follows up from that is the pollinator is hungry and shifts to a different plant. It would promote then what they're moving around, the pollen they're moving around, is whatever is blooming at the time, which is increasingly invasive species. So you would have mismatch between plants and pollinators, the wrong pollen being moved around. The chain reaction to that is that the wrong pollen is then being put onto the other plants. and then they can't get the right pollen, so they also don't set seed. This all funnels down to not getting the right seeds. So there's stigma clogging, there's mismatch between pollinator and plants, relationships that developed over millions of years. And this is just in a few weeks shift of planting seasons. Gardeners in the audience, as well you know, we have shifted here in St. Louis. Our zoning for what we can plant and what we can't plant has started to shift. The other mismatch that happens is then for the queens to be made. They don't get, there's certain plants that often bees, and particularly native bees, need for making queens. So you wouldn't have enough new colonies, you wouldn't have enough queens being made. And these all sound like small things, but this is how the world falls apart. Is lots of little things don't connect, and then you don't have seed set. One of the things we're looking at as a baseline right now is, do the plants, the native plants, need pollinators or not? That's why we're focusing on breeding system. Can they set seed without them, or does it result in inbreeding depression? I think it's fairly confident we don't feel good about inbreeding. A lot of plants feel actually just fine with it, but a lot don't, and you can have a tipping point where the genetics go haywire. And without bees or with the wrong pollen being moved, then you see rapid degeneration of the breeding populations of seeds as well. So those are like a few little things that could rapidly go wrong with even a slight shift between the uncoupling of those relationships. Is that? And then honestly, in 5 years, we're going to have just an enormous amount of information about that. But this is active research happening right now.
Thank you.
Thank you.
Any other panelists want to weigh in? Okay. I think this may be our last question. We're quickly approaching 9 o'clock. I will just state that I think our panelists have agreed to stick around a little bit longer if you still have questions, but I think in our forum tonight, this will be the last question.
Thank you, and thank you all for coming again. So I talk to my dad a lot. He's an 85-year-old guy. He doesn't listen to radio. He doesn't read the internet. He's too busy working. He's out trimming his Christmas trees. He's out planting his garden. He's cutting his own wood. He's 85 years old, and he still cuts his own wood. Our house has never had electric heat that he grows up in. He doesn't know a thing about CO2. Doesn't know a thing about chemistry or methane or any of that. But I asked him about this crazy weather. He said, something ain't right. It's as simple as that. But what he doesn't know is what to do about it. And with your closing comments, could you suggest what we should do about it?
Dr. Titley, do you want to start on this one?
Okay, sure. I mean, I think there's a number of things that we could do. We can lead by example. If you're an 85-year-old person in the community, my guess is you're pretty well respected. So you could talk about the importance of conservation in general, conservation of the land, conservation of the water, respect for the resources, and not in a hippy-dippy trippy way. But I'm talking about, let's say, conservation in like a Teddy Roosevelt way. What the word conserve means. Use judiciously, use wisely. There are things that I think our eldest, our wisest generation can really pass on down. That sort of sets the mindset then, or whatever the technical fixes are going to be that, let's say, the teens and the 20-somethings and the 30-somethings are going to actually implement, whether that's hybrid vehicles, whether that's getting more solar, getting onto more wind power. But the idea is that we're going to use the earth in a way that there will be at least as much left for our children, our grandchildren, their children, rather than less and less and less. And that's kind of where we're going here on the fossil fuels. And if somebody could help move the needle a little bit in that direction in a community, I don't care how much they know about chemistry or anything like that. I mean, because the gentleman you described has tons and tons and tons of common sense. I'll take that any day over book knowledge. And my guess is they perspective, and people are going to listen to them, and that sets those conditions for real change. So people like that can be tremendously influential in the community. That they're gold mines. Thanks.
Thank you, Dr. Titley.
I think the little phrase that was coined back in the 80s of think globally and act locally is what we all sort of have to do. So if we all just keep in mind, recycling will help use less energy, walking or biking if you can, instead of riding cars. There are all these little things we can do, and the trend is positive. I mean, there is a sign that society is slowly thinking globally and doing their part to recycle, for example, not to litter and not to pollute the streams. So I mean, we are making the steps in the right direction. It's just a little slower than we would probably like, but that's just the way it is. We just have to keep on plugging away into our own parts to help alleviate the situation.
I know on the internet you can get 50 things to do to help the planet in your home. These lists exist everywhere, and they're magnificent if you're looking for the nuts and bolts. And do that. Print them out and hand them out and educate your community. The other thing is go ahead and be the squeaky wheel. Write your congressman, write your senator. Be as loud as we can, since that's what works. And then finally, and this is speaking to, of course, what most of my day is consumed with, is educating the next generation. I am fascinated by the students in my classroom, the millennial generation. They show a remarkable core value of caring for the planet that did not exist in my generation, and or was new, was still pegged as a tree hugger. But that as a baseline, they just respond to the need to take care of the planet in a way that I think is fantastic. And I think to promote that and to continue to educate our young people on caring for the earth as a core value is something that we cannot underestimate the impact of. There's a tremendous quote that says, because I am optimistic about the human race and what we can do, to paraphrase it is that we are unique as a species in our capacity for destroying ourselves and our planet. We are unique, but we're also unique in that we can do something about it. No other species on this earth can act with love and care and foresight to change what happens. And that makes me very hopeful for our future.
Those are excellent words to end on. I would like to thank you for being here this evening, your attention, your questions, and perhaps more importantly, what you are going to do as you leave this place going forward to make a difference in our world. And I would also like to thank Dr. Fishman and Dr. Krakos for being here tonight, for Dr. Titley joining us remotely and taking time out of your evening. Thank you very much. We certainly So this concludes. I just want to remind you to be back on October 24th for the second event. And have a good night. If you have some additional questions, our panelists will stick around. With the exception, I think, Dr. Titley, I don't think you can step through the screen. So thank you very much and good night, sir.
I don't think so.